Hello guys, I'm Guru Prasad and currently I'm studying in SVC Bengaluru. I'm from second year IAC department. Today we are going to explain about some of the most important topics that is related to data structure and application. The first one is additional list operations. The second one is sparse matrices. The third one is doubly linked list. Let's move on to the video. In this presentation, we are going to know about additional list operation. What are the operations which is based on the linked list? Next, we are going to move on to the sparse matrices. Then its representation, array representation, and linked representation. Then doubly linked list. What is doubly linked list and all about doubly linked list. Next, first move on to the additional list operation. The first operation is traversing. Second one is insertion. The third one is deletion. The fourth one is searching. The fifth one is sorting. These are all the additional list operations. The first one is traversing. Traversing means we have to access the each element of the linked list. That is called as traversing. Next, insertion. Insertion is we have to add a new element to the linked list. That is called as insertion. Then deletion. We have to delete or remove the existing elements from the linked list. That is called as deletion. Next, search. Find the node in the linked list in the specific position, which is present in a specific position. That is called as searching, which is the binary search. This is the one example for the searching. Next, sort. Sorting is the sort the nodes of the linked list in the specific proper manner. It should be bubble sort or merge sort, whatever, because these are the examples for the sorting. Next, first move on to the traversing of the list. First, displaying the contents of the linked list in a very simple way. These are the steps for traversing the linked list. Next, move on to the temporary variable to the next one and display its contents. Next, when the temp is null, that means the temporary variable is null, we have to know the reach. We have to reach at the end of the linked list so we can get out from the while loop. This is the C function for the traversing of the linked list. Next, the insertion of the linked list. The insertion is happens in a three manner. Insertion at the beginning, insertion at the middle, insertion at the end. The first one is insert at the beginning. The steps to be taken for the insertion of the beginning is first we have to allocate the memory for the new node. Then second one is the we have to store the data. Next, we have to change the next of the new node to the point to head. Next, change the head to point recently created node. This is all about the insertion, and this is the C function for the inserting element to the linked list. Next, move on to the next one, insert at the end. The first one is we have to allocate the memory for the new node. Then we have to store the data. Then we have to traverse to the last node. Then we have to change the next node to the last node, recently created node. And this is all about insertion at the end. And malloc is used for the memory allocation. And this is the insertion at the end C function. Next, move on to the insertion at the middle. First, we have to allocate the memory and store the data into the new node. Then traverse all the nodes before it required to the position of the new node. Next, we have to change the next pointer to include the node in between. We have to traverse each one of the elements one by one to insert an element in the middle. So this is the all about the C function which is present in the insert at the middle. Next, move on to the deletion. Deletion is delete from the linked list. You can delete the either from the beginning, end, or from the particular position. That is called as deletion of the linked list. First one is delete from the beginning. Head is we have to declare one pointer variable, that is head to the second node. Then head is equal to head. This arrow mark will be represent the move to the next node. So head will first it will delete from the first element and it will move to the second element. This is called as head to next. Next, delete from the end. We have to traverse each of the elements from the second last element and change its next pointer to the null. And to delete from the end, we have to traverse all the elements, second last element. Then we have to change its next pointer to the null pointer. Then the end of the linked list which represent the null. So this is the C function for the deletion from the end. Next, deletion from the middle. But we have same thing. We have to traverse all the elements before its element to be deleted. Next, change the next point to the execute the nodes from the chain. And in delete from the middle, we have to traverse from each element before the element to be deleted. Next, we have to change the next pointer to the exclude the node from the chain. This is all about the C function for the deletion for the middle. Next, we have to searching. Searching is a search an element from the linked list. Is we can search the linked list using the loops, and by the step by steps we are finding the items on the linked list. And the steps to be taken for the searching is make the head as a current node, then run the loop until the current node is null because the last element points to the null. If in each iteration, check if keys of the node is equal to the item. If it is the key matches the item, then return the true value, otherwise return false. And this is all about searching. In searching, we are going to initialize one thing, that is key. Key will be used for searching an element. Then searching an element C function is this one. Next, sorting. Sorting the elements is sort the element from the linked list. The most important example for the sorting is the bubble sort. And the steps to be taken for the sorting the elements is make the head as the current node and create another node for the index for the later use. If head is null, then return, or else we have to run the loop till the last node. In the each iteration, follow the following step, and 5 6 steps are the store the next node the current in the index. Then sixth one is check if the data of the current node is greater than the next node. If it is greater, then swap the current and index. These are the steps for the sorting. First we have to make the head as a current node, and we have to create the one more node for the index for the later use. Next, if our initialization head is null, then we have to return, or else we have to run the loop until it reaches the last node. Next, if each iteration follow the following step 5 and 6, the 5 and 6 steps are fifth step is the store the next node of the current in the index. We have to store the next node of the current in the index. Next, sixth one is check if the current node is greater than of the next node. If the current node is greater than the data of the next node, if it is greater, then we have to swap the current or index, or else we have to exit from that loop. This is all about sorting. Next, this is the C function for the sorting. Next is we are going to moving for the next important topic, that is sparse matrices. The sparse matrix is a special case of the matrix in which the number of zero elements is much higher than that of the number of non-zero elements. As a rule of thumb, if 2 by 3 of the total elements in a matrix are zeros, and it is called as a sparse matrices, it means the non-zero elements are very much less compared to the zero elements. The zero elements are very much high in the sparse matrices. This is called as a sparse matrices. This is the representation of the sparse matrices. The sparse matrices can be represented in the two ways. The first way is array representation. The second one is linked representation. The first one is using the array representation. The two-dimensional array is used for the representation of the array. Representation on the sparse matrices using the arrays. In 2D representation, we have using arrays, row, column, and value. The row means index of the row where the non-zero element is located. And column is index of the column where the non-zero element is located. Then the value of the non-zero element is located at an index, that is row and column. In the given sparse matrices, we have rows, columns, and values. The first element is 3. Index value of 3 is 2. So the column 2. Next, the value is 3. The row is 0th row. 0th row, column, second column, the value is 3. Same as all the elements. This is the array representation of the sparse matrices. Next, we are going to move on to the linked representation of the sparse matrices. Same thing, sparse matrices containing the row, column, and value. Index of the row where the non-zero element is located. Column, the index of the column where the non-zero element is located. Next, the value of the non-zero element which is located in the index, that it should be row or column. Next node is the address of the next node. And this is the graphical representation of the sparse matrices using the linked representation. Given the sparse matrices, in the linked representation, we have the 4 things. The first one is row. First column is row. Second one is column. The third one is value. Then the fourth one is address of the next node. The first row, which is containing the 0, that is row number. Next column, it is second column. The 3 is present. The value is 3. Then address of the next node, which is the linked node, which is address the next node. It will address the next element of the 0th node, 4th index, that means 4th column, and the value is 4. In this representation, we are going to represent all the elements which is present in a sparse matrices in this manner only: row, column, value, and the address of the node. This is all about the linked representation of the sparse matrices. Next, we are going to move on to the next another important topic, that is doubly linked list. Doubly linked list, the doubly linked list, which is represented using the linear arrays in the memory, where each memory is addressed to store three components. First component, which will store the data value. Second component which will store the memory address of the next element. The third component is the memory address of the previous element. It will act like a, for example, in the given example, first one is 2. First one is 2 is the value. Then the null is the previous element's address, that is null. The second one address is 100. Second node address is 100. So it will represent the second node's address, that is 100. Next one is 3 is the value in the second linked list. I mean doubly linked list. And 96 is the address of the previous node. 96 is the address of the next node. Then 104 is the address of the next node. And the third one is the 100 is the previous address of the node. 5 is the value. Then the null is the end of the linked list. This is the representation of the doubly linked list. Next, we are going to move on to the advantage and disadvantages of the doubly linked list compared to the singly linked list. The doubly linked list can be traversed in both forward and backward directions. But in a single linked list, we cannot traverse the both in forward and backward directions. The delete operations in the doubly linked list is more efficient if the pointer to the node to be deleted. Then we can quickly insert a new node before a given node, because we can insert the insertion and deletion can be done in both the ways. It should be in forward or it should be in backward. Next, in a singly linked list, to delete a node, the pointer to the previous node to be needed. To get this previous node, sometimes the list is traversed. In doubly linked list, we can get easily the previous node's address and the next node's address using the previous pointer and next node pointers. Same thing, the disadvantages of the some of the disadvantage which is present in the doubly linked list compared to the singly linked list. Every node doubly linked list requires the extra space for the previous pointer. It is possible to implement doubly linked list with a single pointer through see this or this. In the doubly linked list, the memory space, the extra space is required for the previous pointer. It is possible to implement the doubly linked list with a single pointer. So this is the one disadvantage. The next one is all the operations are required an extra pointer previous to be maintained. For example, in insertion, we are going to insert an element to the linked list. We need to modify the previous pointers together with the next pointers. For example, in the following function for the insertion at the different position, we need 1 or 2 extra steps to be set the previous pointer. So this one is the another disadvantage for the doubly linked list, because we have to initialize or require extra pointers for the previous node's maintenance. For this example, for the insertion, we need to modify the previous pointer address also. So this is the most important disadvantage for the doubly linked list. Next, the applications for the doubly linked list, where the doubly linked list could be used. The first one is it is used by the web browsers for the backward and forward navigation of the web pages. Next one is it is used in the least recently used or most recently reached cache are constructed using the doubly linked list. That is called as LRU or MRU, which is the cache, which is constructed using the doubly linked list. Next, third one is the used by various applications to maintain the undo and redo functionalities, because it is two-side. So it can be used for undo or it can be used for redo. So this is the one more application for the doubly linked list. The fourth one is in the operating system, in the OS, the doubly linked list is maintained by the thread scheduler to keep track processes that are being executed at the time. In the OS, in the scheduling, different types of schedulers, we are going to use the doubly linked list for the representation of that schedulers. So that is called as different types of scheduler. The application which is used in the doubly linked list are, first one is the we are going to use in the web browsers, all the things. Then we are going to use in the memories, that is cache memory, LRU and MRUs. Then third one is used to in the various applications for the undo and redo applications. And the fourth one is in the different types of schedulers we are going to use in operating systems. This is all about doubly linked list. In this example, we have given the doubly linked list representation, which is having the actual node, previous node's address, next node's address. It divided into three parts in one single block. That is called as doubly linked list. And the representation of the doubly linked list like this. This is the C function. First one is C function struct node. We are going to create on structure node. in that structure node, we are going to initialize the data as an integer, then structure node pointer to the next variable, next structure node pointer to the previous variable, which is having the previous node's value and the next one's value. Previous one is the address of the previous node, data is the data item, which is having the actual data. The next one is the address of the next node. This is all about doubly linked list. How the representation of the linked list like this. It can be the doubly linked list can be passed in the both the direction, forward and backward. But then in single linked list, we have to move only one direction. This is one most important advantage for the doubly linked list compared to the single linked list. So this is all about doubly linked list and different list operations and the sparse matrices. I hope you guys enjoy this video. So you have learned something. So please utilize these things in the data structure and applications. So please like, share, and subscribe the video. So thank you guys.